back. And we were looking at how to do navigation in 3D. There is a demo project that we could look at, but maybe I'll just kind of look through here and see. So there's, it looks like all their setup is focused around the navigation mesh stuff and navigation server. Let me open A Star 3D and take a look at what it describes here. So I think that it seems like there's a lot of like nodes and stuff for doing it with the navigation server, which is more flexible, right? Because you can be like, oh, wherever you want to go, here's, you can find a route versus, well, they describe it as it's best suited for gameplay where the actors aren't required to reach any possible position, but only predefined distinct positions, right? And this seems to be maybe the thing that we want. That feels like, in terms of like, oh, there's a target that you have to protect that the enemy is seeking out. This is what you would want. What is the path to it? And then what does the enemy... Well, I guess that's a question, right? And then if the enemies have the ability to attack your defenses, they need to... maybe they... Like... Like, what do they do? What is the behavior that we want for the enemies, right? I guess, I guess I'm thinking that there's going to be some combination of, like walls or something you can put down that are like, that block the enemy's path. And there are things that hit the enemies. Let's focus on that first, then we'll figure out like if the enemies can attack your defenses, right? So then it becomes a like, I think a good initial thing will be just like, you make a path and the enemies have to route through the path to get to the destination. I guess we have to make sure that there's there probably needs to be something in the world where there's like an unbuildable area, like you have to, or there has to be a route. Like you can't just like, I don't know. We'll cross that bridge when we come to it. Let's say that. I don't know. I suspect though that like the navigation stuff, server stuff might be useful, but let's just take a look here at what the docs for A Star 3D say. So it's an implementation of A Star. For finding the shortest path between two vertices on a connected graph in 3D space. Uses points in 3D space and Euclidean distances by default. You must add points manually with add points and create segments manually with connect points. Once done, you can test if there is a path between 2 points with the rPoints connected function. Get a path containing indices by get ID path, or one containing actual coordinates with get point path. And there's some examples of doing things other than the default thing, where you can give it like different cost estimates between different locations. If the default estimate cost and compute cost methods are used, if the supply estimate cost method returns the lower bound of the cost, then the paths returned by A Star will be the lowest cost paths. Okay, and then there's just all the methods. And comments, no comments. Okay. Interesting. So what I would imagine would be, To do this, we would essentially have a grid um, map, which would represent like every point in the grid or every tile in the grid would represent somewhere where you could build a thing, right? So every time you place a defense, you are essentially removing a cell from the grid, and then probably paths to that cell, right? So you're essentially removing vertices from this uh, graph. So we can do that. But I want to take a look at what the other option is here, right? So navigation server 3D, and there's a bunch of stuff here, but they have kind of a walkthrough, right? So if you're doing it this way, it uses navigation server 3D and a navigation agent 3D for path movement. So we add a navigation region 3D node to the scene. We'll click the region node and add a navigation mesh resource to the region node. We add a new mesh instance 3D node as a child of the region node. Interesting. Select the mesh instance 3D node and add a new plane mesh. Oh. Okay, so this is, we're making the floor the proper way, not the way I did it earlier. Add a new mesh instance node, select the mesh instance 3D node, add a new plane mesh, increase the XY to size 10, select the region node again, and press bake nav mesh button in the top bar. Now transparent navigation mesh appears that hovers some distance on top of the plane mesh. Add a character body 3D node in the scene with the basic collision shape and some mesh for visuals. Add a navigation agent 3D node below the character node. Okay. Add a script to the character body 3D node with the following content. Okay, so this is their example script. So this, when the character is loaded, we initialize some things. Oh, you give it a movement target position. So like, where does it want to move to? Nice. Actor setup. What calls actor setup? Oh, I see. It's called deferred from ready, right? Okay, so interesting. So sometime after ready, we will wait for the first physics frame, which apparently is going to let the navigation server sync. We set movement target, which is this function we define right below, to movement target position. So we're reading from the this value. I would put I would export these so they're settable on the node. Set movement target just calls navigation agent at set target position. Navigation agent is the navigation agent 3D that's inside of this node. And in physics process, we say if navigation isn't finished, get the current position, get the next position, and then set velocity to be movement speed times the direction that we want to move in. And then physics. Okay, this is nice. Let's just do all of this. Okay, so we're gonna change some things. I think I'm just going to I'm gonna get rid of this static body 2D. We'll do some other things here in a minute. So add a navigation region 3D. Navigation region 3D. And there's obstacles too, which is nice. Okay. Cool. Okay, we'll learn more. Okay, and then it says click on the region node, add a new navigation mesh. And then add a new mesh instance 3D node as a child of the region node. Okay. Okay, select it, add a new plane mesh. Get that. And then we can expand that, and we can set this to be 10 meters by 10 meters. Actually, I'm going to make it like 100 meters by 100 meters. We got some space to work in, yeah? This is nice. This is what I was trying to do before. I guess here's a question. So... that does that, but what about... like if I just run this, yeah, that happens. There's no, it's not collidable, right? Let's just keep doing this and see what. Oh, right. Ultimately, the reason our monkey head is falling is because the character body 2D, or sorry, character body 3D script on it is making it fall, right? So if we don't implement that, it won't fall. So I guess we don't need to have a physics enabled floor, right? That's a problem I made for myself, but it was helpful just to see physics working and things while we were testing stuff out. Okay, so now we need to do this part. Select the region node again and press bake nav mesh. Region bake nav mesh. Okay, success. Yep. Add a character body 3D node in the scene. So we've done all that. We need to add a navigation agent 3D node. So we're gonna go over to here. Rename that. Call that enemy 1. We are going to add navigation agent 3D. There we go. And then we want to copy and paste this script. Cool. And then we're not using delta, so we'll just add an underscore there. And I'm going to add an export. Yep. And then we're going to replace all the tabs with spaces. I'm doing 2 spaces, so there we go. All right. And let's close that for now. And so when we look at enemy 1, we can see it has movement speed and movement target position. So where do we want it to move to? Let's have it move over yonder. So what would that be from a coordinate perspective? Top view. So the floor is, what, 100 by 100? This is like, is there a way to show? Interesting. Okay, view settings. Nope. Let's see. Oh, neat. Okay. Don't really care about that though. Use space, ruler mode. So I don't know, let's target like 60 or something. Let's go back to this. Okay. So the enemy will target like negative 60 to 60. 60, there you go. All right, so if I run this, we should see stuff happening. Ooh, yes indeed. Let's move the camera so the camera can see the whole thing. backward. Let me undo that rotation that I just did. Move this. This. Lower it. Yeah, let's see what that looks like. Okay, movement speed could be faster. Although, I don't know, this is fine. It'd be cool if the enemy, if the the character turned to face the direction that it's going in. We can do that, right? So we're gonna say something like var move direction. I mean, we'll just call it direction. Yeah. Face towards the direction. So look at is a method that exists on Node 3D. And then next path position is what we get from here. I like it. We don't see Suzanne anymore. Presumably it's right here. Let's move the camera so it can see everything. There we go. Have to think about how we want to actually position things. Is that backwards? Seems backwards. And also maybe clipping into the floor. But we can fix that. All right. So, things to fix. So, I mean, it doesn't start clipped into the floor, but it seems to end that way. I think, yeah, we could do some stuff where we have the like, we could have the camera chase this character, but that's not really what we're trying to do with tower defense. Yeah, we will need to add probably just the ability to move the camera to like move horizontally and vertically, fixed at and probably zoom in and zoom out too. Just not being able to rotate the camera, I think, is probably what we'll do for kind of this sort of pseudo. I mean, we could rotate left and right in a way that I don't know. Think about that. The aesthetic that I want is kind of a what if like I still want the aesthetic of it like being 2D isometric or isometric anyway, of like you're looking down at an angle and you can shift from looking from like bottom left to bottom right, maybe all the way around, but you're not able to like free cam. Yeah, something like that. So is there, let's so for the purposes of seeing what's going on with the character, let's move the camera over here. Then let's see, rotation. Let's reset all rotation. So, what I want to know is when we start this, does the mesh sink down? No. Okay, so the appearance of like the chin clipping into the floor was just a perspective thing, and because it was backwards. Um, so let's position the camera over here. Oh, I think I grabbed the wrong thing. There we go. Okay, so yeah, so it immediately. Okay, so this I think is just the issue of the mesh being oriented in such a way that the can we do anything about that? I mean, I guess we can rotate. Ooh, up direction? Vector pointing towards upward used to determine what is a wall and what is a floor. Okay, so I don't think that's going to help us here. Transform. Just rotate around the y-axis. Y 180. Does that fix our issue? So now it should be, nope, that did not, did nothing. What does top level here do? If true, the node will not inherit its transformations from its parent. Node transformations are only in global space. I don't think I want to do that. Why? Let's look at this. Look at rotates the node so the local forward axis, -z, points towards the target position. If param use model front is true, the positive z-axis is treated as forward. Okay. So this is just a matter of doing that. Yep, that's it. All right. Cool. So, and then we can change these parameters, right? We can make it go faster. We can have it go elsewhere. Like we can have it go like x0 50z. Let's do something here where we just have the camera facing down. I grabbed the wrong handle, I think. Because it's already facing this way, so we want to. Okay, the handle's not so great. Let's just reset the rotation, and then we are facing that way. So we're going to rotate around Y 90 degrees, and we'll rotate around Z 90 degrees. Did that work? Nope. What is a Z anyway? Very hard to see. Something like that. So I guess -90. I can only type negative. -90. Yep. And then rotate around. So tisk. Why can't I click the box? There we go. 0. Where am I oriented? pull this camera up. All right. Can we? Let's see the preview. Wait. Okay. I moved this somehow. I didn't mean to. Camera. Oh yeah, great. Let's see. Let's see which direction do I need to go in the field of view? Yeah. Sure. What happens if I increase the near? Nothing? Okay. Okay, visually I don't think this will be too impressive, but we can see the character moving in the direction we've set for it. Or rather, not the direction, but moving towards the location. I guess having done this, let's do at least one more thing to kind of vet out the idea of hold on, which way is the camera facing? So okay, so this is the camera top, right? So we want to be, let's just use this. There we go. So what I want to do is I want to add a obstacle. It's experimental. Interesting. Okay, then maybe that's not the right thing to use for this. Let's go back to the docs really quick then. So using navigation maps. A navigation map is an abstract navigation world on the navigation server identified by the navigation server RID. A map can hold and connect a near infinite number of navigation regions with navigation meshes to build the traversable areas of a game world for pathfinding. A map can contain avoidance agents. Okay. Navigation obstacles. Interesting. Obstacles and agent avoidance. For avoidance, navigation obstacles can be used either as static or dynamic obstacles to affect avoidance-controlled agents. When using statically, navigation obstacles constrain avoidance controlled agents outside or inside a polygon-defined area. When used dynamically, navigation obstacles push away avoidance-controlled agents in a radius around them. Oh. What does it all mean? I don't know. Let's just ignore the fact that it said it's experimental and just add it. Okay. And then give her to the camera preview, and let's just do give me a top orthogonal view and immediately destroy it. Shift. Okay, there we go. So that's this. If we move, oh, neat. Are we? What are we doing here? Okay, I managed to connect them finally. Come on, get out of my way. Out of my way. I'm trying to draw. Okay, so I made a mesh instant. No, sorry. Navigation obstacle. There we go. Okay, I'm just trying to. There we go. Okay, cool. Very nice. All right. So, what does it do? I don't know. A height 1 meter, radius 0. What is that? What does that look like? So I think the idea is that stuff won't try to pass through this area, right? Let's see what that looks like. It doesn't work. Great. Do we need to rebake the navigation region? Bake. Does the navigation obstacle need to be inside of the navigation region? Maybe. Let's try that. Are there settings in the enemy navigation agent? Avoidance enabled. Excellent. Oh, there are avoidance layers too. Interesting. So is this going to change course? Nope. All right. I tried. Let's see, height. The height of the avoidance agent. Agents will ignore other agents or obstacles that are above or below their current position plus height. And 2D avoidance does nothing in 3D avoidance, which uses radius spheres alone. Okay. Radius. Change an actress pathfinding radius bake navigation meshes. Different navigation mesh dot agent radius property. Okay. Navigation region, navigation obstacle avoidance. Yeah, enabled. Use 3D avoidance. If true, obstacle affects 3D avoidance using 8. Okay, we need to turn that on. Flip winding. Clear vertices. So this is all about the vertices inside of the navigation obstacle. Okay, so let's try this. If this doesn't work, I will also try rebaking the navigation region. Seems like it doesn't work. It's going straight through. And it's like, yeah, I'm pretty sure that is the direction. Let's try rebaking. Is there, I wonder if this is something where, these don't interact properly. I should read more docs. Let's try one more time. Let me do one more thing. So can we add a mesh? I just want something I can visually see to know that we are in which direction we're going in. So we're going to create a box mesh. Sure. And then the material will be a standard material. Can we... Oh, let's just resize it. Just want something I can visually see on camera to kind of orient. It's not going to, yeah, okay. So that is the correct direction. And it should be avoiding this region, but it's not because I'm doing something wrong. An avoidance obstacle is considered static when its vertices property is populated with an outline array of positions to form a polygon. So we did this. Static obstacles define their boundaries with an array. Okay. In the case of 3D with an additional height property, I think the height should be fine here. We can make it taller. Just to make sure. What is radius in this context? That's the avoidance radius for the obstacle. Okay, so avoid that much. See if that does anything. Seems like no, because it should be avoiding. Okay. What if I don't know how this interacts with the navigation mesh stuff. I haven't read that far ahead. Static obstacles can't change their position. Static obstacles that are warped can't be predicted. An avoidance obstacle is considered dynamic when its radius properties. Okay, so we don't need radius here. Okay, let's get back to the top here. So, dual purpose. Affect navigation mesh enable. The obstacle will affect navigation mesh when baked. Aha. So, this makes it affect it. I guess we can turn off avoidance enabled. So this should do what I was trying to do, where I'm trying to rebake the navigation mesh. Yep, there we go. So that just carves out the navigation mesh. There's something I must be... Yeah, so there. Like, it navigates around. Very nice. Now, of course, it makes no sense. Like, you know, I have the cube here, but, you know, the region that I'm avoiding is much bigger. It's not being visually reflected, but that's just because just trying stuff out, right? So it seems like there's two ways of doing it, right? One way that affects the navigation mesh, and another way that affects the avoidance mechanism. Avoidance is enabled by default. If the obstacle is not used for avoidance, disable enable avoidance to save performance. For navigation mesh baking, okay. So is there? So if I move this out, oops, if I move this out of the navigation region, and I unclick this, okay, and I enable avoidance, and then I go back to the mesh region and I bake it. That resets that. So the question is, why does what do we need to do for the navigation agent to do avoidance? So we have avoidance enabled. If true, the agent is registered for an RVO avoidance callback on the navigation server 3D. When velocity is set and processing is completed, a safe velocity is received. With the signal connection to velocity computed, avoidance processing with many registered agents has significant performance costs. And should only be enabled on agents that currently require it. Neat. Use 3D avoidance. Okay. That's probably what I was missing there. So now we've unbaked the navigation mesh and we've turned on avoidance. Do we avoid? We do not avoid. Probably missing some things. Okay. So... when 2D avoidance is used in 3D, the y-axis is ignored. Excuse me. So you're supposed to put the navigation obstacle 2D as a child of navigation region 2D for it to work. Okay. So they say. Let's try that. So we put the navigation obstacle back into the region. Although they're talking about 2D, not 3D. Maybe this will work. Otherwise, I'm I'm missing something that would make the agent care about it. So something to figure out, because I think there's something to be said for using the obstacle, because we have this kind of dynamic environment, because the alternative would be that we have to rebake the navigation mesh every time we are dynamically changing the map by putting down defenses. Okay, well, I have some things to dig into a little bit more, but I think it is approaching lunchtime for me, so we're gonna pause here for today, and I think we have a lot to figure out in making a tower defense game. So that's what we're gonna do in upcoming streams. But for now, let's see if we can find someone to rate.